Welcome to Gossip About Gossip, powered by Hedera Hashgraph. In each episode, we'll cut through the hype of blockchain promises and explore real-world examples of organizations creating the next generation of decentralized applications, which will bring trust back to the internet for us all.
Hello, and welcome to Gossip About Gossip, the podcast where we talk about real-world applications for distributed ledger technologies. My name is Zenobia Godschalk, and I'm the SVP of Communications here at Swirlds Labs, helping to develop the growth of the Hedera ecosystem. Today, I am delighted to be joined by Paolo Tasca, who is a longtime member of the Hedera community. He is a professor at UCL. UCL is, of course, a member of the Hedera Governing Council, and he is also the co-founder and executive director of the Center for Blockchain Technology at UCL. Hi, Paolo. How are you?
Hello. Hi. Nice to be here. Thank you for the invitation. Very glad.
Absolutely. So today we wanted to talk about native staking on the Hedera network. And we had announced a few weeks ago, we shared a blog post on phase one of native staking, as well as what that process will look like to roll out, fully functional native staking on the network. For those who are newer to the story and sort of newer to proof of stake, can you talk a little bit about why staking is important for a proof of stake network?
Yes, thank you for this question. So, staking is fundamental for proof of stake because it aligns the network security with the individual incentives. And these are two important aspects. Let's look at the incentive first. So the proof of stake is fundamental that provide basically the right incentive for each node to stake and to achieve basically an agreement on the order of the transaction and eventually at the end the settlement that all these transactions. So there is a fundamental difference between the incentives in a proof of stake systems and in a proof of work system. So the proof of stake system is able to work with a low block rewards. So the level of rewards, it can be relatively slow because basically there are two components that characterize the incentives for the participants. So one is the initial coin holding, so the stake, which refers to the total amount of coins that these nodes of stake basically use, and is computed just to the point of, before the minting, and the block rewards itself. So when you are in a proof of stake system, you have these two components in mind, and if you contribute in a benevolent way to achieve consensus, then you indirectly increase the value of the native coin. So even with a sufficiently low block reward, you can basically shift things and drive each stakeholder to prioritize basically the generation of this consensus, regardless of the other strategies of the other stakeholders. So these basically imply good equilibrium, and these basically enable to achieve consensus in long term in any state. So this difference arises because the proof of stake require all validators to hold these native coins they need to stake. It's a sort of, let's say, positive feedback loop that require this requirement basically ensure these rewards to shift these validated incentives, and by maximizing their basically holding by validating and providing good consensus. So they don't have the incentives to to misbehave or a malicious attack is relatively lower than a proof of work. In proof of work, indeed, we don't have this mechanism of incentive because validators do not need to hold any native coin. So this is a problem because low block rewards does not align the incentives toward maximizing the value of the native coin. So rather, reducing the block rewards indeed undermine the incentive of validators to participate in the validation process. So that's the part of the incentives that I think is very important for proof of stake. And I think this is why Hedera was also conceived and designed on proof of stake. And there is also the second part, which is about security. Basically, the proof of stake is a mechanism that basically force every node and every staker to basically commit some level of collateral, let's say, in order to for them to not break the rules. So they put their skins in the game, so to say, right? So the more others that stake, indeed, the more secure is the network, because these basically reduce the probability of civil attack, which is when basically some nodes colluded to create a false transaction or to do some bad things in the network. So the larger the network, the higher the cost for proof of stake attack. So opening up the network with proof of stake, I think, increase also this level of security.
And so for those who are not as familiar with Hedera's journey and, sort of path to decentralization, why is this important for Hedera, which has typically had all of the nodes run by council members?
Yeah, well, council members basically is a consortium, you can call, of leading institutions and organizations that achieve trust and consensus off-chain by formal agreements or arrangements or by co-memberships and in committees or working groups. So is a limited number, permission number of members, which well-established reputations and, as I said, off-chain agreements. Though Hedera started in this permission way, so to say, it's basically nature to become an open, public, fully decentralized blockchain started back in 2018, where in the white paper back then, Hedera put basically the roots for this journey to happen. And over the last years, basically, we have moved toward a kind of a closed permission network to a more open network. And we are going to be more open and public and decentralized. This is important, is extremely important, not only for Hedera, but for the whole blockchain ecosystem, because public blockchains are the backbone of many decentralized applications. And if you imagine also the new Web3 and DeFi world that are exploding, these are generally built on a public blockchain that are proof of stake consensus run, and generally they are also very keen to look at the sustainability of their consensus mechanism. In this respect, let me say that Hedera is well positioned in the market, and one of our recent research at the University College London showed indeed that Hedera is the best of breed in this case. So, but going to the benefits of having this public blockchain rather than a permission blockchain, what this means. So this means basically indeed a larger developer community. This means basically a larger developer interest. This means basically that there is an arrangement that could be also for the development of code-based updates and even development of layer 2 applications. So this for certainly is something positive. Second, there is also, let me say, I was a former central banker, and I have to take this angle sometimes. So having a public blockchain which is fully open and transparent and permissionless improve, let's say, the regulatory standing and positioning of the ecosystem of the blockchain itself within the ecosystem, within the markets. And this is true both in the US and Europe, looking at the current regulatory landscape. And finally, I would say that having an open IP of the code base, having a transparent and open access to the code can lead, to further development. And I'm thinking about the works that are basically run by the international bodies for standardizations. And I had the honor to chair one of the first, indeed the first subcommittee of the ISO standard TC307, which is still called Taxonomy and Terminology. And I think that having an open technology like Hashgraph, this can basically lead to further adoption and consideration by these international bodies. So ultimately, I think this will lead to greater market adoption.
Yes. And Paolo, the flip side of, that openness and, open to everyone is that obviously there are more security concerns. And so can you talk a little bit about the unique security attributes of Hedera's staking model?
It is kind of unique. Let's say that in Hedera we have kind of infrastructural attributes. And based on these infrastructural attributes, we can have some emerging feature of this infrastructure. So if you look at the infrastructural attributes of the data, we have what we call the virtual voting, which is a kind of a virtualization, if you want, of the voting-based consensus mechanism, which although be one of the most robust asynchronous solution to the Sybil attack problem that in the decentralized network is really difficult to deploy and inefficient and sometimes not even fair. So Hashgraph is a solution, if you want, to this problem, and it used the principle, the mathematics behind the voting-based system, and virtualize this. So, and instead of voting, basically, this is done through message passing, gossiping. And basically, we generally talk about gossiping about gossip, right? Which is basically the solution that enable everybody to have a complete set of information of all the history of the transaction occurring in the network. And if we have these complete pictures, then this makes it easy to predict with probability 1 what will be the vote that will be cast by HBAR without need for them to cast the votes. Basically, this is the infrastructural attribute that I was mentioning. And this means basically that cryptographically is impossible to broadcast false information in the data network. The worst case scenario, someone can withhold information, go offline, or choose not to broadcast the information, gossip information, but he cannot gossip false information. And this brings to some emergent properties. So the emergent properties that make Hashgraph consensus mechanism unique is the fact that basically through this virtualization of the voting system, we don't need a bonding, so we don't need a lockup period, generally happening in the proof of stake system. We don't need slashing, basically punish the malicious behavior, and we don't need new coins to be minted every time there is an achievement of the consensus, and this also prevented the inflationary problem that some of the crypto suffer in the proof of stake world. So Hedera is unique in this respect, and if you want to take a bird eye view, we can say that Hedera is a kind of a mix, if you want, with the Hashgraph, consensus, a mix between the proof of stake and the delegated proof of stake, because basically you can use this type of validation to staking without the need for election of delegates, which is generally something that happens in delegated proof of stake.
Lots of good benefits that you went through there. Thank you. I think one other question that we get is around emissions rates. Can you walk us through the emissions rate for Hedera, with native staking?
Well, I cannot talk much about emission rate because we have been talking a large the CoinCom, which is this tokenomics and committee at Hedera, and will basically be decided in the upcoming meeting, and will be voted by the council in the next meetings. So I can talk about not what will be the emission rate, but I can talk about how we achieved our decision on what will be our emission rates. So it is important maybe for the people to understand the decision that how this decision was produced. But basically, we will support our decision by building from scratch a tokenomics model, an original economic model, basically, that we have designed and implemented over the last year with the support of an international team of economists and a complex system scientists. And we did this from scratch. So let me say that we need to understand that most of the economics model that are out there that try to understand the DLT system lack of formal scientific foundations and the modelings, and they're not able to model incentives in a proper way. So most of the economics of these real world DLT have some generic heuristics, are based on some poor assumptions, and sometimes some too strict assumptions that create frictions or create economics imbalance. And this is true for most of the proof of stake and proof of work networks are there. So in Hedera, what we did is basically to start from scratch by looking at the basically Hedera architecture, technically speaking, and then from there we derive basically the economic model that will drive the incentives for the users. And basically this model is composed of multiple sub-models nested within each other. And this model describes basically the dynamic of important components and variables. So the model is able to give us predictions of important dynamics. And we use the model as a kind of navigator and to infer what the dynamics of the system is. So some of the dynamics the model will able to give us is apart from the emission rate, of course, is the cumulative reward that that will be paid out over time. For example, the dynamic process of the cumulative fees collected over time. The accumulation rate of the reward account 0 to 800. We look at the macro variable, like also the optimal reward dynamics process, the wealth accumulation of the users and the nodes and the stakers, and finally we look at some we predict some level of fairness by looking at the wealth accumulations of stakers and nodes, so looking at the coefficient like the Gini coefficients, inequality index, and we look at the Nakamoto index for the nodes. So let me say that the Nakamoto index is very important because it represents basically the number of nodes that would be required to collude together in order to successfully slow down the network or attack the network. And in our study, which is now published and will be used exactly for the emission rate, we have found something very interesting about the Nakamoto index in the long run, not now, we have done prediction in the long run, and we have seen that in the long run, once the Hedera network will be public and open, more decentralized than ever, the Nakamoto index will stay stable around 40%, which is super interesting because the general Nakamoto index of other blockchains like Polygon is 2%, Solana is
that's a big difference.
Yes, Solana is 1.52, Phantom is 4.5 something. So this level of robustness, which is basically remain stable in the long run, even when the system will be open and public and fully decentralized, is something that we found really, really astonishing.
That's fantastic. Well, I think we are probably all excited to see that research when it is ready to be shared. Paolo, before we wrap up today, I think this is probably a question on the mind of a lot of folks in the community. What do you think? Can you walk us through the steps of what it will take to get to phase 2, 3, 4? True, fully functional, robust staking on the Hedera network, and sort of why we have to go through that phased approach.
Yeah, I mean, without going into much of the details, I think the idea behind it is to have a right equilibrium between the adoption, the adaptation, so to say, of the business ecosystem around Hedera and the technical implementation. So it's like basically launching a rocket. It's not something that you launch in 1 second. You need to activate different
right.
And you need to prepare a lot of setting around the rocket. So that type of phase resembles that type of rocket launch. So we already somehow, we are in the phase 2. Phase 3 is more technical, and phase 2 basically will enable us to exactly prepare the setting around the launch, meaning engaging more closely with the wallets, with the exchange platforms, making sure that there is a level playing field, whereby all the users have the right access, the same access, and that they're not preventing to the staking opportunity. So we want to prevent basically the winner take all, so that the more informed and user and staker can get a higher reward. And that's why also we put a cap on the APY, the annual return, which will be 6.5, which is, to be frank, relatively high compared to the market, but this is important to put this cap to prevent this type of to guarantee this type of fairness. And the phase 3 basically is basically a technical development that will come after phase 3. So I cannot basically exactly tell you a date when we will move from phase 3, 4, but because this depends actually on the alignment of these different works that we are doing both on technical side and the business side. But I can tell you that it will be very, very soon, and it will be basically done. According to our internal plan, which is basically quite soon. So I'm happy to see that despite the current let's call winter period, the Hedera never stopped. The Hedera indeed accelerate, speed up toward its decentralization efforts. And this basically, I think, will bring us new opportunities. And when I say us, I say for the whole blockchain ecosystem. So we need a blockchain like Hedera. So soon the reward will be activated full speed.
All right. Well, Paolo, thank you so much. I think we would love to come back and check in with you as Hedera's staking develops and matures. But thank you so much for sharing your time and your insights with this audience. I think that was very helpful.
My pleasure. Thank you to you for having me here.
All right. Have a good one.
Thank you. Bye.